Kalyani Government Engineering College. He will be introduced by Dr. Susmita Lama. And so, Susmita Lama, please.
So you have to let me. Good morning, everybody. Today we have a very eminent resource with us for today's session, Dr. Satyendra Nath Mandal. Talking about Dr. Mandal, Sarendra Nath Mandal received his BTech, MTech, and PhD in Computer Science and Engineering, working as an assistant professor in Department of Information Technology, Kalyani Government. Just a second, sorry. Kalyani Government Engineering College, Kalyani, Noida, West Bengal, India. He received Career Award for Young Teacher from AICTE 2010, and he received two Best Research Paper Award, COMSYS 2020 and ICACA 2021. He received Alan Perles Teaching Excellence Award from the International Multidisciplinary Research Foundation 2022 from IMRF Institute of Higher Education and projects. His two patents and three copyrights have been sanctioned from Government of India. He received two ICAR certificate for his two developed technologies. He has research collaborations among 8 research institutes in India. His current field of research areas includes image based on individuals and breed animal identification, image-based plant disease identification and quantification, hyperspectral imaging for early possible disease detection, etc. He has about 150 research papers in national and international journal and conferences. So I would like to welcome Dr. Mandal for today's session. Thank you for your time, sir. Over to you.
Yeah, thank you, Susmita. Just 1 minute. হ্যাঁ দাদা আমি চলে যাবো, আমি ক্লাস আছে। Actually, I'm the man of computer science. May I audible? Am I audible?
Yes, sir, you're audible.
Yeah, I'm the man of computer science, but last 10 years, I'm working with the agriculture people. And today, I'll show what I did without going the technical details. And there are lots of work we have done. But today, I'll want to give you the flavor. What is can be done. There is lots of field, or we can participate in the agriculture field. Is it visible?
Yes, sir, it is visible.
Yeah. My topic is the application of AI in agriculture. And some part also what is actually agriculture mean. We are at general knowledge. We are seeing the agriculture that's but as a ICR the agriculture as a whole. That include the animal, they include the fisheries, they include the other things in the agriculture. Now, what we are working in the current scenario? We expect 9.6 billion, that is 10 billion people in the earth by 2025. But all of them need to be fit. Now, what is the problem? The problem is shrinking, and also due to modernization, pesticide loading is increasing in the land, so we lose the huge amount of crop. So we have two options. Either we can grow huge amount of it to feed all of them. Otherwise, we can do some work to reduce the crop loss. And our research mainly focus on to reduce the crop loss in the first predominant. Now, this is our traditional way. If one farmer sees something is happening in the field, they call it a crop count. Then you inform to the farmer, farmer consult with dealer or retailer, and they give some pesticides and they brought it and spray in the field. If some farmer are advanced, what they did, they consult with the university expert or Kabi expert or expert from the government wing and give, and they take their suggestion and go to a dealer, take some pesticides or fungicide and spray in the field. But before that, they lose some days, and there is lots of dead-end disease in agriculture field. Within that disease, they lost their crop, whole field. Then some of them commit suicide. Then what is the solution? As a scientist or as an engineer, so these are my first work was, sorry, yeah. Now, my first work was and surveillance the most important disease of mustard plant using the quadcopter drone, using image processing. So there is dead end disease, just like lead bite in potato, seed bite in rice, alternative leaf bite in mustard. They worse or they ruin the field within a week. And that was our first suggestion. If we can develop a drone, that drone, if we give the path and set the latitude, longitude of the particular field, and drone can move within the field in using autopilot, and it taking the picture. After that, we can analyze the picture. If we get some problem happening in the field, then what will happen? The drone will automatically set the coordinate. This portion problem may happen. Then second drone or maybe the same drone, we can put some pesticide and in particular position they can spray it. We did a lot of work using the concept, and we find that that is the working, and some modification is needed. This is the first one. Suppose we capture that something is happening in the field. This is the leaf picture, and this is the on potato field. These fields contain the late blight disease. In agriculture sciences, they are marking the intensity of the diseases. Intensity means what a state of diseases. They are marking it stage 0, stage 1, stage 3, 5, 7, 9, or some of them give 1 to 10 based on the area of effect. Now, the problem is they are estimating the intensity of disease through eye estimation. What we did, we capture some photographs and send to the different life still level of expert, just like who is working on the potato disease, university student, university teacher, and the who are scientists working in the research field, a research center. But we get the different response. Most of the thing they're confusing about the level 3 and level 5. And if they're confused, then what will be the status of the farmer? Then what we did? We changed the scale. We changed the manual scale into the image-based disease rating scale. Based on the scale, the pesticide dose we are designed, and you can spray the field. What will be the advantage? From eye disease detection to expert and a dealer, we lost the 3 or 4 days. But using this technology, within a second or within a minute, we can determine the dose, and we can inform to the farmer, go and spray it to reduce the scope. Same thing we did on the Homa bite. Homa bite always happening in the West Bengal. It's a state of West Bengal. There is some small spot happen on the leaf area. It reduces the photosynthetic area. What is the effect? The T bodies become the less. So same thing we did our concept. We developed the new disease scale and tested it, and we can tested that then we can reduce the crop loss using this concept. Now, if it's a large scale, what will happen? Now, we develop a deep learning model. In deep learning model, also we can feed in the mobile. We can develop the mobile apps. Behind this, deep learning model can work. If we just simply send to the apps to our farmer can take on photograph within the second, he or she can also predict what is the status of his field and what is the intensity of the disease. Based on that, the pesticide will be designed, will be prescribed, and he can buy, he can spray his field. Now, it's the very, very important thing. Earlier, all our work we did after happening. Can you do something before incident of diseases? In that case, we develop a system or technology using a hyperspectral imaging. For example, if we have fever at night, at the afternoon, we just feel some uneasiness. The same thing is happening in plant. If some disease is coming, so before that disease, the something is happening in the field. If we can track this field, So before the indigen, at the level 0, we will spray the pesticide. So if we see the spectral signature, the normal leaf and with the disease only coming, and disease came and at the end of the disease, so every time the spectral signature is different. If we continuously follow the field, if the spectral signature is changed, then we will inform the farmer something is happening in your field. Just go check and spray your disease and pesticide. Now, this is our work in the field level work. And here, the problem is disease. When the disease will occur, no one can say. If disease is not occur, then our experiment will be failed. Then what will? Then, if we create disease in the laboratory, then we do our experiment. That is why we inoculated disease in the laboratory and check whether our concept is working or not. We inoculated disease and we see that in laboratory environment, before 3 days of actual incident of disease, we can predict something is happening. And based on spectral signature, we can predict which disease is coming. And same thing we apply in our field level. This is the experiment we do on the powder leaf in our garden. Now, this is the another problem and the types of problem which we did some work. We want to identify the plant, the potato variety. There are lots of variety in the market. So anybody can say these are something is called is the Chandramukhi, someone is the Orun, someone is called other potato, but which is actually, and with help of the Bidhan Chandra Krishi Vishwavidyalaya, based on the image technology and based on our deep learning system, we have developed the software which can identify the potato plant, also the tuber, based on the image. So our technology can confidently say which the type of the or which the variety of the potato plant. Now, before all the work we did based on the image, based on the deep learning, based on some machine learning. Now we collect data, the environmental data, using our IoT model. We develop IoT model in our laboratory to collect the environmental parameters, that is the maximum temperature, minimum temperature, humidity, as well. And we put this device on the cucumber field to predict the incident of another dead end disease is called the downy mildew. The downy mildew is the dead end disease of cucumber beet. Is a drastically reduce the photosynthetic area and tuber become less or yield become less, or after some day we lost the field. And after collecting the data, we using the deep learning model to predict the actual time when the disease may occur. So if the environment is favorable for the disease, we inform to the farmer the environment is favorable, downy mildew may come, please go and check. And after some time we can say the downy mildew will come. Now another thing we do with the that's all for the plant. Now some work we done on animals. So sometimes we this work we did with help of the Uttarbango Kisi Vishwavidyalaya in poultry farm. What happened in the poultry farm? In summer season, they are panting. They are not taking the food. That's why they are drastically we are losing their weight. And now all the farmer, the contact farmer, they are getting money based on their weight. So if these players ways, they are losing their profit. Then what we did? We put IoT device to in poultry farm, and we are collecting the temperature, humidity, carbon monoxide, carbon dioxide, ammonia, moisture, etc. And after that, P5 level. But P dependent level are the theoretical. Also, we can calculate P dependent level to place. And if this is some gases or some temperature go beyond this hour, some precaution they will take. Suppose if temperature beyond the tolerance level, some sprinkle will on. And if the or fan will on. So this type of work we have already did. And if the farmer use this, maintain this system, RT system in their farm, they are not losing the weight of the chicks. Now, in West Bengal and all over India, not in all over India, and all over the world, there is another concept is integrated farming. Because nowadays, if one farmer is they are farming only one type of crop, that is called the monocrop. Monocrop, they are farming only the 3 or 4 months. After the 3 months, they are just become idle. That's why the farmer are changing the concept. They are same field, they are use the multiple crop throughout the world. So they transfer monocrop to multiple crop. But what will happen if they want to farm in such a way that the residue of one unit will be the input of the another unit. If we put this circular way, that is called the integrated farming. Integrated farming is the closed loop. the residual of one type of cord or one type unit go to the input of the animal. Suppose if some farmer, one farmer, they have some paddy field, so residual paddy field is straw. Straw can feed the cow, cattle. The residual of cattle, we can put it on a farm field. Also, if we need some water, we can use some pond. On the pond, we can put some fish and a residue of cattle we can put on the pond. So this is the integration. And that case, if we maintain all these things, then what will happen? The livelihood of the farmer will be increased. But what is our job? Our job is, and they are not calculating how much land is needed, which portion will be the field, which portion they can use for pond, which portion you can use for the cattle, how many cattle they must be maintained. In that case, we develop the AI tools based on the rule base, based the profit, based the requirement, based the livelihood, and we develop some algorithms. And if we follow this algorithm, if we simply, that will be the help center, farmer help center. They maintain one software. If some farmers came, he tell only we have some amount of land. So the one hectare land. From 1 hectare land and where he stay in. Suppose we cannot study the farmer who stays in North Bengal and farmer who stays in South Bengal. We cannot tell the farmer who stay in beyond to the market. So there is lots of technique. We'll give the suggestion using the proper utilization of fund, proper utilization of field, proper utilization of paddy area, so that the output will be the maximized and their livelihood will be increased. Last one, the next one. So as you see from the picture, this is the Aadhaar card. So we are maintaining the Aadhaar card. What is the use of Aadhaar card? To identify our identity. So how to develop an Aadhaar card? Simply we take the image, then we can ID this image, face image. So they are maintaining this type of software. And they are maintaining a database. If your fingerprint is not matched, you will not get allowed. You will not get any SIM card. And if we match, then we will get everything. Now, what will happen? If we use now, according to biology, their call is a trait. So based in Aadhaar card, we use on the fingerprint, we use in the face, we use in the IDs. And these are the traits we can use for individual identification. We can use the retina, we can use the ear, we can use the nose print, we can use the venation pattern. Now, what will happen if we want to develop the Aadhaar card of an animal? Because there is no insurance of an animal, only the Bajaj insurance there, but farmers are not getting so much. Suppose we have 100 cows and same breed. We have 100 goat. But how do individual identify? So we want to vaccine all the goat, but they are looking the same breed. But how to identify them? Then what will happen if we want to develop an Aadhaar card? And we did this work on goat and pig with the help of Enerson pig, Enerson goat Mathura, Enerson pig Assam, Enerson meat Hyderabad, and Uttar Bango Krishi Vishwavidyalaya, and with IIT Guwahati. So what is our objective? What was our objective? To identify the individual animal as well as the breed. So first suppose our Aadhaar number is some digits, we have developed their number. This number, from this number we can get their breed, their farm, their location, their number, their state, everything. First we decide what will be the number, just like our other number. Then we develop the scanner code. If we scan, we can get everything. Now, what is the technology behind it? They maintain a traditional way. They can brand it, they can cut their eye, they can put the tag. This is the temporary marking. But all of them cruelty to the animal. Can you do something without touching them, without harming them? Can you identify them? Because identification is mandatory. To take their pedigree, to give the vaccination, to insure them, to select for breeding. Then what do we do? First, this is first our development. We mark. We have seen that we tested their all trait. Trait means the organ. First we look, is their eye is unique or not. Then we check whether his ear is unique or not. We say the concept. So some trait already developed for human which keep the unique identity. Then our objective was, can we find out some organ they behave like a human organ so that we can identify them? We first select their eye. So this is the labeling of human eye. We have an eyelid, we have a pupil, we have a sclera, we have an iris, we have a limb mass. Can we identify them? But the problem is, before our experiment, there is no label picture label picture of eye in the internet, in the whole world. Then why I did? We take the picture and label them, consult with the veterinary people, consult with the all specialists, eye specialists, and finally we consult with these guys. He's the CEO of American Animal Institute. He said, if mark, this is where mark, the mark you individually and send to me. And he return the correct labeling. Then we get this portion is pupil, because our eye, if we see from the distance, our iris and the pupil looking the same. But in case of element, this is the pupil, the iris, and limbus, cornea, all are the same. Then our objective, if there is any pattern or not. If there is a pattern, then question comes, this pattern is available for all animal or not? Same species. Same species. Species means the goat is a one species, cow is a one species. Third question is, if this pattern is present from the birth up to adult or up to date, if the pattern is not present, then we cannot use for the identification. If the pattern is not present in just newborn baby, then we cannot use it. Then we have to do some experiment when the pattern will stable. So we have did lot of experiment on it, and we work on the goat. And what we did? First we capture the picture, then we segment the eye, then eyes normalize the eye, then we generate the template, then we store in the database. Again the same way we capture the picture and matching. Now the problem is, greatest problem we face that they are not communicating. If they are not communicating, how to get their picture? Because when you capture once, the natural looks may not be repeated in whole life. And how to match them? Next, in human, we have already established 50% of using 50% iris, we can identify the animal. So what would be the minimum requirement iris for identifying the animal? There are lots of questions we face. And we did this one. Now, another thing. There is no camera, no iris camera, specially made for animal. That was our biggest restriction. We use the human iris capture, eye capture iris camera to identify the animal. That camera we have used. Now, next problem. Our eye is the circular structure. And goat iris, their pupil is the rectangular. No one has any idea what is the structure of the eyes. So all experiment, all algorithm developed by the human identification will not be used for animal. So what was the problem? Problem for acquisition of image, because they are not communicating. There is no camera which is specially made for the animal. There is no developed algorithm. There is no developed concept. So how do you do that? So we solve all concepts by one by one. Now, this is the way. We set the head horizontally. We capture the multiple times. Our objective was to capture at the maximum as possible iris without glare. So if glare is present, we're not getting getting any pattern. If the position of glare is changed, then the pattern will be changed. Then this is the whole steps. तो image को sir. And this is the pre-process the image, segment the image, normalize the image, encode it to get the template, finally matching it, and this is the match. Now we face one problem. If we get the multiple picture from same animal, their matching accuracy, we get the image from the different animal, their matching accuracy, the difference is not so high. So what was the problem? Now the problem was our image type. This is the monochromic image. The monochromic image will not work for large sets of animals. Then what we did? We use this type of tool. We have developed tool, we get patent, and these are the same. These are all my PhD student, master student. And we capture using DSLR camera with macro mode. And then we get, this is the pattern. And there is, we got the huge gap in the match or non-match. If we get the multiple picture from a same animal, they are matching accuracy. If we take the two different animals, their matching accuracy is the different. So in this concept, we can individually identify the goat using their iris. What is the beauty of this iris? It's a non-invasive matter. Non-invasive means without simply without harming them, we can take the picture. We also did same work using a retina, but in retina is the invasive method. We have to put some atropine on the eye to take the retinal picture. Now, second portion for individual identification, we did on peak. But same thing, if we apply on the peak, it will not work because their anatomy structure. If we look their eye, their anatomy structure so that we cannot get the iris. Then what will happen? Now we will try their snout. Snout has some pattern. But the problem is there is some saliva always. If you put them saliva, the light will reflect. And there is lots of difference between the two images. Then we tried on the ear. Now see that. When you see the close to the ear, there is some venation pattern. And this venation pattern up to secondary level, they remain fixed up to their lifetime. And if we can track the ear venation pattern, then we can give their identity. But how do we get it? Then what do we do? We put one strong light one side of the ear and we can take the picture opposites of the ear. Then we take this type of picture. And from this picture, we do our calculation. We segment this picture, we get the mention pattern, and we track their branching point, distance between the two branching, their angle, and we put it all the information in the database as a template. Then again we recapture it. Again we recapture it. If we recapture it, then again we match, and we match it, and we have seen that the matching accuracy of the same different year of the same peak is totally different from the other one. So that's year variation pattern. If we put the year variation pattern as identity, then we can identify individually of peak. These are the steps: pre-processing, year segmentation, year normalization. This is the point, and template, and the matching. Then matching. So we say the threshold. Below this threshold value, they are match. After this value, they are non-match. These are the non-match. Now, this is the individual. From the working with the animal science, they are maintenance because with the human, with the breed. So breed means within the cattle, suppose the goat, there is different type of breed. The Bengal breed, Jagrana breed, Jobnapari breed, they lost type of breed. They identify breed by the measuring. Suppose this is the breed. They measure their height, their color, their ear pattern, the alignment of the eye, alignment of the snout, their tail structure. So there are lots of those. And their time goes in. What we did? We simply take the picture and simply develop a deep learning model. Based on the deep learning model, we can identify them. Simply, this is. We capture the huge picture, and among the picture, we separate them, training and testing bit. Using training, we develop a deep learning model. Based on a deep learning model, we identify them using test tables. As the Ganyam, Sangamari, Gaddi, these are them. Now, also, we separate the beat using their coat color. This hue such a value. Now, without deep learning model, if we capture their photograph based on their hue value, if we separate from the picture, we calculate the HSV model in the hue value, hue saturation value, we find that the hue values differ from breed to breed. These are the values. Their range totally different. So based on their range, we can identify their breed. These are the values. Niang Mega, Javaski, Nicobar, these are the breed. If we see the maximum, minimum, all value, so within the range, we can identify their breed. Now, what is the challenge? So every point we face the challenge. So our model, our technology is working fine. But this model is not work in some place. It's the confusing because we are working with the natural element. Now see, according to animal science, left side is a black Bengal goat. Their coat color will be black, their structure will be like this, but all in the picture, all the black Bengal goat. This all the black Bengal goat. So how do you identify which one is the black Bengal goat? So sometimes the machine will confuse. Next, this is the Assam hill goat. It looks like same like the black Bengal goat, but they are separated them as a Assam hill goat. Now this is the Osmanabadi goat. This also same look like the if the challenge. This is the challenge. This is the look is the same. Then machine may confuse, but first one is the black Bengal goat, second one is the Assam hill goat, third one is the Osmanabadi goat. Now, this is the challenge. Upper two, they look the same, but first one is the beetle, second one is the Siroi. Then see, first one is the Totapuri, breed, Totapuri, and last one is the Jogna. So these are the problem. There is a huge problem we face when you work with the deck. And see, one is the large white EXRP, one is the land nose. And these are the information we have collected. Just 1 minute. Hello. Oh, wait, just wait. Okay, Purna building. Okay, just a minute. And after developing some technology, we sit with the farmer what they are necessary of the technology or not, what is the feedback, we have collected the feedback, and we tell them use this technology. Finally, our objective, we develop some technology, we have to develop the technology which will accepted by the farmer. And this is my output. I have 2 patent, 3 copyright. We have developed Android F5. We have already just completed 7 funded projects. I have worked with the DVD, DST, ICAR, AICT, and that's all. Thank you.
Ah, thank you, sir. Thank you for your interesting topic. You have discussed your research. The research is very interesting, but participants may have some questions.
Yeah.
Participants, if you have some questions, please.
So because this is the list of my 10-year research, so that's why as the multiple participants are in this program, that's why I'm not going in technical details. So I give the overview idea. If you have any problem, any technical question, so then you can ask me.
Probably there is no question. Sir, may I ask you
Yeah.
if there are any uh, app, AI-based app for small scale farmers
Yeah.
who can use it for their farming?
Yeah. There is lots of it. There are
Please
the
name some.
yeah. There is lots of apps. If you go to the Google or Play Store or ICAR website, there is lots of app for and we have developed also the different app, and also you can conduct we can get some apps, because now what is the modern research? Modern research, people are using the IoT to collect the data. Based on their data, they are using the deep learning to process all this data to get some output. Now they feed the output to the mobile apps so that anybody can use it. This is the track. And problem is most of the apps is not interactive. We have developed some apps, the interactive app, and some of the ICR app, if we put some question, the question will go to the expert. Expert will give the answer. After that, you will get it. So that is also the time consuming. So our apps, if it simply take the picture or give a query, within that time, you will get the result or you will get your answer. You can go the in addition peak Assam, you can get our apps. Also the Google Store, you can get our apps.
Oh, thank you, sir.
So, thank you very much.
Now I ask Professor Susmita Lama for vote of thanks.
I would like to express my sincere thanks to Dr. Mundal for giving us his valuable time and enlightening us with the knowledge on application of AI in agriculture. Sir, we are very much grateful to have you for this session. Thank you so much.
Thank you.
So, on behalf of Kabi Nazrul College and Manbhum College, I extend sincere thanks to all the participants for their active participations. I hope tomorrow, in tomorrow's sessions, there will be a lot of participants because particularly the students will be benefited from tomorrow's sessions. From tomorrow's sessions, we shall know we will prepare the students for app-based research and education. So, thank you. See you tomorrow.